What's up, guys? Welcome back to the channel. Today on this video we'll be doing this question paper that you see here on the screen. So this is mathematics in 5, and this question paper was actually written 25 November 2025. It was an X paper which was written for 3 hours. So on this particular video we'll focus on question 3. So just in case you want to watch the other two questions, which are question 1 and 2, I'll leave those videos on a playlist on the description, and also the very same playlist will pop up on the top right of this video that you're watching here. All right, before we begin, we're gonna leave timestamps for each and every questions, just in case you want to watch a specific question. You don't want to watch in a sequence order. Now, before we start though, I'd just like to say thank you very much, guys, for watching, subscribing to the channel, commenting, and not forgetting those who like and share the videos. Now that we're done with the introduction, how about we look at question 3 and solve it? Here is our question 3. As you can see, question 3, it consists of 20 marks, so it has lots of questions here. So we're gonna start with 3.1, and then we're gonna do other questions later on. So let's create some space and let's solve 3.1. All right, here's our question 3.1. 3.1 also has question 3.1.1. So let's look at this question here. First of all, we are given the following, the function there, f of x is equal to x cubed minus 3x plus 5. So this is the function that we'll be working with 3.1. So 3.1.1, they want us to determine the coordinate of the turning point. Now this here is a cubic graph, guys. For the fact that it has x to the power of 3, it means that it is a cubic graph. So now they want you to calculate the turning point. So when you calculate the turning point, this means that you need to derive this function that is given to us and equate it to 0. Right, so let's find the coordinate. So first of all, we derive this. So when you derive this, it's going to be f of x prime is equaling to the derivative of x to the power of 3 is going to be 3x to the power of 2 minus 3. All this is equaling to 0. Do not forget, guys, whenever you are calculating the coordinate of the turning point, when you derive, you will always equate it to 0. So since it's like this, we can transpose this negative 3 to the right hand side. So we're going to be left with 3x squared is equaling to, if we transpose this negative 3 to the right hand side, it's going to become positive 3. And then we divide by 3 throughout them. There we go. So x squared is equaling to 1. But now we are not looking for x squared, we're actually looking for x. So we have to square root both sides here to get rid of the square there. So the square root of x squared is going to be x, and then the square root of 1 is going to be plus or minus 1. There we go. So this is the x coordinate of the turning point. One is positive and the other one is negative. So we need to find the y coordinate of the turning point. So you can say when x is equaling to positive 1, what is your y? So you need to find y there. It's very, very simple, guys. All you have to do is substitute this x value, which is equaling to 1, to the original equation there. So we can say y is equaling to, so as you can see, our original equation, we have x to the power of 3. Instead of writing x, we're going to write 1 there to the power of 3 minus 3 multiplied by x, but this time around we're going to say 3 multiplied by 1 plus 5. So you put this on a calculator and then you'll get your answer. So if you put this on a calculator, our answer here is going to be 3. There we go. When x is 1, our y is going to be 3. Now we can call this turning point 1 when x is 1, and then y is going to be 3. Right. So how about when x is equaling to negative 1? What is our y? There we go. What is our y? There's a question mark there. So we're going to do similar with what we did before. We're going to take the original equation, and this time around we substitute -1 wherever there is x. So let's do it. Y is going to be equaling to, now open bracket, -1, then we have cube there, minus 3 multiplied by -1 plus 5. Now you have to put this on a calculator. If you put this on a calculator, your y is going to be 7. So turning point 2, here we go. When x is -1, y is going to be 7. So this here is our answer. So we have two turning points there. Remember, they want us to find the coordinates of the turning point. I hope you guys managed to understand this. Really, it was not that difficult to do. Just in case you find it to be difficult or you got confused somewhere, you can go and watch at the point where you got confused. And if that doesn't help, you can always leave a comment on the comment section, ask a question. But if this part of the video helped you to understand how to calculate the turning point on the cubic graph, you can always like the video, share the video, and if you haven't subscribed to the channel, subscribe to the channel. All right, people, we are done with 3.1.1. How about we do 3.1.2? All right, here is our question. 3.1.2. Now let's see what is it that they want from this question. They want us to draw up a table of x and f of x, where x is ranging from x is equaling to -3 to x is equaling to 2. So basically here they want us to draw a table from -3 to +2 on the x-axis. So let me just draw the table and then let's insert the values there. All right, so here is our table. Remember, they said it should be from -3 to +2. As you can see, it's starting from -3 to +2. I hope you can see that. So what you need to do here is to substitute the values of x on the original equation. So here's our original equation here. F of x is equaling to x cubed minus 3 x plus 5. So basically what you do here is you substitute these x values here on the original equation. Whatever you get, you insert underneath on f of x box there. So let's start with when x is equaling to -3. So if x is equaling to -3, you have to substitute it here on the original equation, and then you will get your f of x. So let's do it. Let's use our calculator. So when I substitute -3, I'm getting -13. There we go. Now let's go to the next one. When x is -2, when you substitute it here on the original equation, what do we get then? I'm getting a 3. There we go. Now let's go and do -1. When x is -1, what do you get then? I'm actually getting 7, right? And then when x is 0, what do we get then? I am getting 5. When x is 1, what is it that I'm getting there? I'm getting 3. And then the last but not least, when x is +2, what am I getting? I am getting 7 there as our f of x. There we go. So guys, basically this is what they wanted you to do. We are done with this question, guys. I don't think this question was difficult for you, but just in case again you didn't understand, you can leave a question on the comments, and if you did understand, you can also like the video, share the video, and also don't forget to subscribe to the channel, share this video to your friends, and don't forget to hit the bell notification as well. Now let's go and do the next question, which is 3.1.3. all right guys, here is our question 3.1.3. Now let's look at this question here. As you can see, here's our question there. Now they want us here to draw a neat graph of f of x between these values, showing the turning point on it. So we're gonna use this table that we just did to draw our graph. Also, we need to show our turning point that we got earlier on this question here, which is question 3.1.1. So let's draw our graph. So I'm going to draw the graph on the right hand side here. Let me first draw the Cartesian plane. All right, so here is our Cartesian plane, guys. So let's draw this graph using the table that we did earlier on 3.1.2. All right, so let's start with the first point here. The first point goes like this: x is negative 3 and f of x in this case is the same as y. It's negative 13. Negative 13, it's somewhere close to negative 12 here. So I can say at this point here, this is our negative 13 there. And then our x is going to be negative 3. So I have to draw a line there. And our x is here, which is going to be negative 3. So make sure that you don't draw a very visible line, only fainted lines like this. Wherever they intercept, that is your point there. So this is my point here. We have the second point here where x is negative 2 and y it's positive 3. So as you can see, negative 2, there we go. Here's our negative 2 there. And our y is positive 3. So if you take a ruler, a driving line, this here is going to be our point. There we go. And then we go to this point here where x is negative 1 and y it's 7. So negative 1 is this one here. You can draw a line that is going upwards. There we go. Now y is going to be positive 7. So since we don't have 7 on a y-axis, we can assume that 7 is a little bit above this point here. There we go. At this point here, we can say our x is negative 1 and our y is 7. Now let's continue. So as you continue here, this is the next point. Our x is 0 and our y is 5. So x is 0 on the y-axis. We are fine there. And then our y, it's 5. So 5 is way below this 6 here. So we can put it somewhere there. You can say this is 5. There we go. Now let's do this point here where x is 1 and y is 3. Now we're going to draw a line here on 1. Let's do it. There we go. And then also 3, we're going to draw a line that is horizontal as well here. So this here is going to be our point there. As you can see, this is also our turning point. I almost forgot about our turning point. This is also our turning point there. And then the last point here where x is 2 and f of x is 7 or y is 7. So we draw a line that is going vertical like that, which is 2. And then 7 is supposed to be somewhere here as well. Draw a line that goes like this. Say this is 7 there. So let's connect the dot. So here is our graph. Remember, we need to write the turning point. Let's start with this one here. This turning point here, x is negative 1 and then y is 7. This one here, x is positive 1 and then y is 3. There we go. So do not forget to write these turning points. As for other points, even if you don't indicate them, it's still fine. Right, I hope you guys managed to see how we draw this graph. It was not that difficult. Again, people, it required you to know how to do the table in order for you to draw this graph. Just in case you got confused on how to draw this graph, you can always leave a comment on the comment section or rewatch at the point where you got lost. And if that doesn't help, leave a comment. If this part of the video helps you to understand how to draw this type of a graph with this method, do not forget to like, share, and also comment on the comment section. And if you haven't subscribed to the channel, subscribe to the channel. We are done with 3.1.3. Let's go and do 3.1.4. Alright guys, here's our 3.1.4. Now we have a statement here. Let's read the statement and analyze this question. So the question goes like this: given that x is equaling to negative 2, 3, it's an approximate root of the equation x cubed minus 3x plus 5 is equaling to 0. Use Taylor's method or Newton's method to determine a better first and second approximation of this root. Open bracket, root correct to 3 decimal figures, close bracket. Guys, this question here, they want us to use Taylor's method or Newton's method to find the approximate root. So we already been given this root here, which is negative 2, 3. Just in case you don't know what that root is, basically that root is an approximation of the value of the intersection there on our graph. That's the reason why I left this graph here, so that you can know what exactly is happening here. So that negative 2, 3 is an approximation of the point there on the x-intercept. So on this question here, the one has to find two approximation of this route which are way closer or more accurate compared to the one that is given to us. So as you can see, they say the first and the second approximations, meaning we're gonna only do two approximation and then we are done, right? So let's start analyzing. So before we analyze them, we have this formula for Newton's method or Taylor's method, and the formula goes like this. We have x n plus 1 is equaling to x nth minus f of x divided by f of x prime. So this formula here is a formula that we're going to use to calculate the approximations that they are asking us to find. So basically what we're doing here, we're trying to find the accurate value of x-intercept by using this formula here. So to explain it further, when you get the same approximation, it means that that is the correct answer, or that is the one that is very, very close to the correct answer there on our x-intercept. Now let's first label here. We have x0. X0 is actually the one that is given to us there, which is negative 2 comma 3. So we need to find x1 and x2. So x0 will be part of xnth there. So we need to find f of x and f of x prime there. So first of all, let me write f of x here. Our f of x, as you can see, is the question that is given to us is x cubed minus 3x plus 5. There we go. And then our f of x prime is the derivative of f of x, which is going to be 3x squared minus 3. There we go. So we're going to use these to calculate the values of f of x in our formula and f of x prime in our formula. So let's start by finding our f of x. Instead of writing f of x, how about we write f of negative 2 comma 3, and then we just substitute with negative 2 comma 3 wherever there is x there. So let's do it. So let's substitute negative 2 comma 3 to the power of 3 minus 3, and then we have negative 2 comma 3 plus 5. There we go. So from here we just use our calculators. If we use our calculator, it's going to be negative 0 267. There we go. So this is our answer for this one here. For f of x prime, but this time around it's not going to be f of x, it's going to be f of negative 2 comma 3 prime, negative 2 comma 3 prime, but it's based on this derivative here. So wherever there is x, we're going to put negative 2 comma 3. So we have 3 multiplied by negative 2 comma 3 squared minus 3. So what do you get there? I'm getting 12 comma 87. Remember, use your calculators, guys, to make sure that you get the right answer. Now let me just highlight here. This one here, when you substitute on the formula, it's gonna go there on the f of x, and that one there, when you substitute on the formula, it's gonna go there on f of x prime. So let's do some substitution. So let's create a little bit of space here so that we can able to get the right answer. Now we find x1. So x1, the formula is gonna go like this. It's going to be x1 is equaling to x0 minus f of negative 2 comma 3 divided by f prime of negative 2 comma 3. So basically we're just going to substitute the values that we have there. All right, we don't have enough space. Let me erase our graph because we don't need it anymore. We can continue from this. So we know that x1 is equaling to, now instead of writing x0, we're gonna take this negative 2 comma 3 because that is x0. We're gonna write negative 2 comma 3 there. There we go. Minus, remember the formula says minus there, and then we have to insert this f of negative 2 comma 3. F of negative 2 comma 3 is this one here, guys. We just did some calculations, so make sure you put them inside the bracket there. So the answer is negative 0 comma 267 divided by, now if you continue, look at the formula, this is divided by f of negative 2 comma 3 prime, which is a derivative there. which is gonna be this one there, which is gonna be 12,87. There we go. So you put this on your calculator to find x1. As I put this on a calculator, I'm getting the following: negative 2,279. So this here is our x1, is the first approximation. Now it's time for us to find the second approximation. We do the very similar thing that we did before when we were looking for x1. We need to find our f of x and our f of x prime. So this time around is no longer f of x negative 2 comma 3. This time is f of x negative 2 comma 279. Remember, now we use x1 now. There we go. So this is going to be equaling to, so we're going to look at the original equation. Wherever there is x, we're going to substitute with negative 2 comma 279. Let's do it. Negative 2 comma 279. Let's not forget this is cubed. Minus 3 multiplied by negative 2 comma 279 plus 5. So if you put this on your calculator, what is it that you're going to get there? I'm getting 0,0002. There we go. Right, before we continue, remember inside the bracket there, they said we must have our answers in 3 decimal points. But the problem is after 3 is still 0. So if it's like this, continue until you insert the number there. All right, so let's continue. Let's find our f of x prime in terms of negative 2,279. So let's do it. So f of negative 2,279 prime is going to be as follows. So we're going to substitute that negative 2,279 on the derivative. So it's going to be 3. Wherever there is x, we must substitute negative 2,279. But let's not forget this is squared minus 3. So what I'm getting here is 12,581. There we go. This is the answer for f of x prime, or f of negative 2,279 prime. Right. Again, we're going to apply the formula. So this time around, we are looking for x2. Now let's write the formula. So we're going to have x2 is equaling to x1. Remember, when we're looking for x1, this part here, it was x0. Do not forget that. Minus, now the formula doesn't change, still the same. We have f of negative 2,279 divided by f of negative 2,279 prime. There we go. So this is the formula. Now it's time for us to do some substitution. Before we do that, let's create some space. All right, so let's do it. So x2 is equaling to x1. Remember, x1 is this one that we calculated earlier, guys. So don't forget that. So it's going to be negative 2,279 minus, then inside the bracket, we need to put f of negative 2,279, which is this one here, which is going to be 0,0002, divided by f of negative 2,279 prime, which is this one here, which is going to be 12,581. Then close bracket. Then you insert this inside the calculator. Your answer I'm getting here, it's negative 2,279. So it doesn't change as much. As you can see, this here is x2, the same as this one here, x1. Basically, this method that we just use is to get the root or the x-intercept closer to the correct one. Since it doesn't change that much, it means that our answer is actually negative 2,279. This here, guys, is how you do it. I hope this video helped you to understand how to solve this type of a problem. If it so happened that you didn't understand somewhere, you got lost, do not forget to rewatch at the point where you got lost. And again, if that doesn't help, you can leave a comment on the comment section. But this is how we actually do this question here. Again, people, if this video helped you to understand, do not forget to like the video, share the video to your friends, and also if you haven't subscribed to the channel, subscribe to the channel. All right, people, we are done with 3.1.4. Now that we are finished with this one, let's go and do 3.2. All right, guys, here's our 3.2. Now let's read the statement there. As you can see, now the statement goes like this: a particle moves along a horizontal line according to S is equaling to 1 over 3 t cubed minus 2 t squared plus 3t, where S is the displacement in meters at time t in seconds. So guys, we are given this formula here. Now this formula is the formula for displacement, and then S it's for displacement, and t is for time in seconds. So the displacement is in meters and then time is in seconds. Now this part here is what you call rate of change. So basically what you're going to do here, you're going to use this formula to answer the questions that follows. So the first question on 3.2, which is 3.2.1, they want you to calculate the displacement of the particle after 2 seconds. So we already been given the formula for displacement. All you have to do here is substitute. Remember, t it's 2 seconds. So wherever there is t, we just have to substitute with 2. So the formula goes like this: we have s, right, which is going to be equaling to 1 over 3 open bracket. So wherever there is t, we have to substitute with 2. Remember, this 2 seconds there stands for time. Let's not forget we have cubed there minus 2. And then again, we have t squared. Instead of writing t squared, we're going to write 2 squared plus 3. And then instead of writing t, we're going to write 2. Right, so whenever they say calculate the displacement and they give you time, all you have to do here, you just substitute the time there. Wherever there is t, you put 2. So you put that on your calculator, and what I'm getting here, it's actually 2,3 or 0,667 meters. Guys, do not forget, we are calculating the displacement. Always put the SI units. In this case now, for displacement, it is meters. So this here is your final answer. Really, this was not difficult. Just in case again you didn't understand, please do not forget to leave a comment. I'll try to answer it to my level best. But if you manage to understand this, do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed. We are done with 3.2.1. How about we do 3.2.2? All right, 3.2.2. Let's read the question. Here's our 3.2.2. The question says find the velocity at time t and after 4 seconds. So basically what they want here is for us to find velocity. How do you find the velocity in a formula like this one here? Remember, this formula here, we have to use it through and through. Now velocity is as follow. So you have to derive this formula, the original formula here, in order for us to find the velocity. So let's derive it. So you can write it as ds over dt, or you can also write it as v of t. Then you derive it. What's the derivative of 1 over 3 t cubed? This is going to give us t squared. If we do the derivative here, this is the standard derivative, guys, minus, and then the second term is going to be 4t, and the third term is just going to be 3. There we go. So this here, you're going to use this formula to calculate the velocity. Now look, you are given the seconds, which is 4. So this time around, we're going to substitute 4 wherever there is t. So you can say v of 4 wherever there is t, we're just going to put 4 there. 4 seconds going to be 4 squared minus 4 multiplied by 4 plus 3. So if you put this on your calculator, your velocity is going to be 3 meters per second. Do not forget, guys, velocity it's always in meters per second. So this is your answer here, guys. Remember, when you calculate the velocity of this particle, you need to derive the displacement formula so that it can be the velocity formula. So this is basically how you calculate the velocity. Okay, people, we are done with this question. Just in case you didn't understand, you can rewatch the point where you didn't understand. And if that doesn't help, please leave a comment. I'll try to help you to my level best. But if this video helped you to understand, do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed. We are done with 3.2.2. How about we continue and do 3.2.3? Let's look at 3.2.3. This is the question there. Now the question goes like this, guys. At what time is the particle at rest? Now the question, they want us to find the time at which this particle is at rest, when the particle is not moving. So what you need to know is that when the particle is not moving, there is no velocity. So earlier on, we did derive the displacement formula, and then we said v of t is equaling to t squared minus 4t plus 3, right? But then when this particle is at rest, this means that v of t, which is our velocity, it's 0. So meaning we can say t squared minus 4t plus 3, this is actually the formula for velocity, is going to be equaling to 0. So when it's like this, we need to find t. So from here, we need to factorize. So how are you going to factorize this? Let's open the brackets there, guys. Let's open the bracket. So we know that the factors of t squared is t and t, but the factors of 3, when you add them, they give you 4. It's 1 and 3. So 1 and 3, when you multiply them, they're going to give you 3, but when you add them, they're going to give you 4. But we need to put negative and negative there. So when we continue, our time is going to be 3 seconds and our time is going to be 1 second. Remember, they said you must find at what times. Remember, times, not time. It's possible for us to have more than one set of times here. So it's 3 seconds and 1 second. So these are your times at which your object was at rest or was not moving at all. So I hope you understand this, guys. Just in case you didn't understand, again, do not forget to rewatch the point when you got lost. And if that doesn't help, comment on the comment section. And again, if this helped you to understand, do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed. We are done with 3.2.3. Let's do the last question of this question 3, and then we are done with question 3. All right, here's our last question. Now, last question is 3.2.4, which is this one here. It goes like this: find the acceleration at time t and after 4 seconds. So acceleration, how do we calculate acceleration? Now let's start from the beginning. Remember, we have the displacement. It goes like this: we have 1 over 3 t cubed minus 2 t squared plus 3t. This is the formula for displacement. When we derive this, which is going to be ds over dt, or which is the same as v of t, which is the velocity, we're gonna have t squared minus 4t plus 3. So this here is the first derivative, which is equaling to the formula for velocity. In order for us to find the formula for acceleration, we need to do the second derivative. So you can do it this way: second derivative, right? So is d squared s divided by dt squared. All this is equaling to a of t. A, which is acceleration, by the way, it's going to give us the second derivative of our formula, which is going to be 2t minus 4. So this here is our formula for acceleration. Guys, whenever they say calculate acceleration and they give you the time there, you need to do the second derivative. Right, so all you have to do here now is to substitute our time, which is 4 seconds from the statement, on our formula. As you can see, we have 2t minus 4. So wherever there is t, we put 4 there. So it's going to be 2 multiplied by 4. Remember, our seconds from the statement is 4 minus 4. So if we continue, a of t, which is acceleration, is going to be 8 minus 4. And then this is going to give us 4 meters per second square. Guys, do not forget this is acceleration, so this s is gonna be squared, so it's meters per second squared. Guys, do not forget to write the SI units on this type of questions. If you can pay attention to this question and you've done science, you notice that the same as science. It's just that we are using differentiation to calculate velocity and acceleration by deriving the formula of the displacement. I hope you guys managed to understand this part of the question. Really, it was not that difficult. What it needed you to do is to understand what is the first derivative equivalent to, the second derivative, what is equivalent to, and when the object is at rest, what is the meaning of that, what is the value of the velocity when the object is at rest. But other than that, this was very straightforward. I hope you guys managed to understand this. Just in case you didn't understand, go to the point where you didn't understand, rewatch the video, and if that doesn't help, you can always comment on the comment section, guys. I'll try to help you to my level best. But if this part of the video helped you to understand how to solve this type of a problem, do not forget to like, share, comment, and also subscribe to the channel if you haven't subscribed to the channel. Guys, we are done with question 3. Thank you very much, guys, for watching. Till next time. Cheers.